let's begin, guys. The very first thing I'd like to address is why do we need to study and understand proofs? So some people, they go into this class and they get very upset because they think I present a material in a way that is more difficult for them to understand it, or so they think. You can see what's available on my website regarding the book, and if you are happy with it, you can use that. If not, again, so this book is you can obtain it, and you can buy it, you can obtain it, but you have some access. Okay, so again, guys, right? So one question that I hear all the time. So I try to explain a topic, I try to understand a concept, I get carried away, maybe excited, and then what do I hear? Is it on the exam? Or how useful is it in real life? And all that tells me is that you are completely uninterested. This means completely uninterested in what I just said. And when you ask, is it useful in real life? That means you want to make it useless. You understand? You already come up with an answer. You say, "Oh, I don't want to hear about it." Right? And I want to be, because I'm not understanding it, and because I don't feel I'm good at it, I want it to be useless. That's really psychologically what you communicate to me. I also like poetry, and mathematics is very much, in some sense, like poetry. And I was reading this. It's a translation from Russian. You can hear how it sounds originally right over here. This, in some sense, is what I imagine will happen with you in this course. That's what you will feel. So read it afterwards. It's posted on my website. So how many of you guys have watched 12 Angry Men? How many of you were able to obtain the movie and watched it? Great, Kirill. Thank you for lifting your hand. You can either type, guys, and please, guys, I really would like to hear your voices. It's very quiet here. I feel like I'm talking to myself. So whenever you want to say something, unmute yourself, and I would like to hear your pretty voices.
I couldn't find the movie, so I just read the synopsis. Is that okay?
Well, it's always, you say, it's not a requirement. What we're doing today will hopefully be something that you might enjoy.
Oh,
yes?
okay.
And it's again, right? So I hope you are ready with it, right? And the question is really why I want to ask you to watch this is, you see, one thing that I wonder is, well, how good do you think, or how good do you believe that you think? So were you the jury? Do you think you are able to think objectively? What do you think? And answer to me, guys, by the way, one more very important thing is, I hope I don't intimidate you in the list, and that you feel very comfortable talking to me. You can speak your mind. You don't have to agree with me. You don't have to, you can just say, I disagree with you, or I think otherwise, and I will be perfectly happy, just as if it's a reasonable discussion, right? What people do very often, it's like they're, I don't know what's to say about it. They are feces throwers. It's like this, right? So when they have an argument, the argument is like this usually. So each person will not give an inch. If person says A, the enemy says B. That's pretty much how people argue. And that's, maybe that's good for winning a fist fight, but it's not good for understanding anything at all, right? If you are inflexible, you don't understand anything at all. And again, right, I would like to show the first lesson. I would like to perhaps suggest that maybe mathematics influences your life more than you think. Maybe. And you will, if you disagree, please tell me that you disagree. I would, again, be very interested in your disagreements. So, can you think objectively? Would you be a good jury? Can you see anything at all without any bias? So, here is one question first. You are invited to a household, and in this household there are two children. You have never seen these children and have no prior knowledge of anything about them, but you just know that this household has two children. As you park your car, you notice one child is playing in the yard, and this child is a girl. Are you with me? What is the probability that both children are girls based on this information? And I would like to see what you would tell me. So text, or whenever you think you're ready, tell me what it is.
Isn't the probability 50%?
Thank you so much. And Who spoke? Alexa, correct?
Alexa, yeah.
Good. How many of you think that the answer is 50%, guys? And again, obviously, I haven't taught you anything about probability. Maybe the question makes no sense to you, but you perhaps have a sense of what probability is. So guys, think about it and let me know what you imagine the answer to be. 50%, yes, 50% as well. One person said 25, and a bunch of people say 50. I would like you to participate. I have, guys, what, 39 individuals. Please tell me what's the probability. Agreed, agreed. Sorry. So many of you say 50%. Great, we're reaching a consensus. You are the jury, guys, 50%. What about more, guys? Everybody says it.
There's a 100% probability that one of them is a girl and a 50% chance that the other one is a girl.
Okay, so again, you agree. The question is that what's the probability that two girls, both of them are 50%? Okay, I'll wait a little
75.
75 that both are girls, yes?
Yes.
Okay, thank you for your inputs. Continue, guys. If you have any more, right? I want to see what you say. We need to see how you think. And if anybody would like to tell me now their argument, say for 50%, so many of you said 50%, would anybody volunteer and tell me why 50%? Right? Argue it, right? Tell me, why is it 50? Why not another number? So Gabriel says not enough information. Okay, thank you, Gabriel. It's interesting. One person says 25%. And Kirill says 1/3. Interesting, interesting. And before you proceed, guys, before you proceed, I would like to hear an explanation for why some person said 50%. Please. Don't be shy.
Hello, can you hear me?
I hear you. Irvin, speak up.
So we know that one of them is a girl, so that's 100%, and the other one could be a girl or boy, so it's 50%.
I see, because each child independently, when it's born, assume that to be true. We're not going to argue that. It's either a girl or a boy. Good?
Yeah.
Okay, so most of you said 50%. Now let's see what's the right answer. The right answer, guys, and one person said it actually, is 1/3. It's not 50%. Now, why is it 1/3? Here is the mistake that you have made. Let me explain to you what just happened. Okay. Now, what truly happened? You are correct that each individual is equally likely. We can assume that equally likely to be a girl or a boy. So each individually is 50% likely to be a girl. But what we have not witnessed necessarily, we don't know if we are watching the younger or the older girl. There are two children, one is the older, one is the younger child, yes? Are we seeing the younger girl or the older girl? So truly, what are the possibilities? We know that the children are either girl, or boy, girl, or girl, boy. Because either we are watching one of the two girls, or we are seeing that this girl is the younger one and the boy is the older, or we're seeing the girl is the older child and the boy is the younger. And each of those outcomes is equally likely. That is, the probability is 1/3. Now, many of you have not responded, guys, and I'm not sure what reaction you have. Are you kind of excited, or you're, oh my God, right? What just happened here is, where if it were a trial, you would have reached an incorrect decision, a majority incorrect conclusion. I hope you understand why it's a girl. And here is the next question. Here is the next question, guys. And and please show me your curious, interested faces if you manage to wake up, of course. Yeah. Here and now, her mother comes to you and she starts yapping around. And then one thing that you hear, this child that you are witnessing was born on a Wednesday. Understand what happened now? So most of the conversation you kind of spaced out, and then you just hear that this child that you're watching, this child was born on a Wednesday. What is the probability that both children are girls now? Has it changed? I want to see your answers. You can think a little bit. So a lot of people say no. It's very nice to see that people are thinking about it. And again, guys, I know it can be embarrassing to stare at some strange old men through the camera and actually show your faces, but please, right? You cannot imagine how lonely it gets here. You know, most of this time over this long isolation, do you know, I haven't even been mentally here. I spoke with people from Germany. That's pretty much my communication. Outside of a few immediate family members, I only spoke to people that live in Germany and some in Israel. About that, I will mention soon. What the mother is saying is irrelevant to the main question. Do you all reach the same consensus, my dear jurors? My dear, smart, intelligent jurors, young people, our future. I'm sorry, don't take it. I'm just trying to entertain you. Okay? And again, not only entertain you, I'm trying to lure you in to come to my probability class, right? So that you understand what it is, so you understand what real mathematics is. Okay, any other questions? So many people say 1/3 information has not changed. Am I right? Anybody wants to add more, or am I stretching the mystery too much? Obviously, we all agree. And some people say it's 1/2 now. So some people change their opinion. Okay. Should I reveal the answer? And the answer is, guys, it is 13 divided by 27. Do you hear me right? 13 divided by 27. So none of the answers that you mentioned, exactly what? None of the answers that you mentioned is correct. Not 1/2, not anything. It's exactly 13 out of 27. Will I see your faces? I want to see amazement, or but you bother us, right? Okay, and should I tell you why? Here's what happens is that you are not selecting the right object. You're too focused on the fact that if the child is a girl or a boy, right? That's true. That's what we are interested in, but that's not the information you're presented. You are actually updating what your information is. So it's a mistake to think that gender of the children is the only relevant information for that particular question. If we assume that each child is equally and independently likely to be born both a girl or a boy, then and we assume that we have the date. So let's say each day of the week is equally likely, right? A person, I don't see why a person is more likely to be born on a Monday or on a Tuesday or on a Wednesday. Let's suppose that this is true, that each day of the week is equally likely. It doesn't mean that's true, by the way, right? But assuming that each child is independently either a boy or a girl, and each child is independently born on any day of the week, what you're witnessing, this is the information. It's a vector with 4 parameters, where the first parameter is the gender of the older child, and the second parameter is the day of the week when the child was born. The next parameter is the gender of younger child and the day of the week that the person was born. Okay, and each of them creates many possibilities. So what you have witnessed is the following. You have witnessed an older girl born on a Wednesday and no knowledge about the younger child, or younger girl was born on a Wednesday. That's what you witnessed. You understand? So it's a vector of this parameter. How many vectors are there of this form? And guys, if you're if something is confusing you, let me know. What is that? What is that something, right? So look at this. Look at this vector. So how many possibilities are there, right? First is girl, second is Wednesday, so this cannot be changed, which means we are only having control of second and third parameter. Do you understand? So there are here 2 possibilities times 7 possibilities. There are 14 possibilities for this event. There are 14 possibilities of this event, and they have 1 overlap. The overlap is where both are, it's the vector girl Wednesday, girl Wednesday. The probability that both are girls and both are born on a Wednesday, and that's the one overlap. Okay, so it's 2 times 7. So this is 2 times 7. It's 14 plus 2 times 7, which is another 4, which is another 14, but minus 1, and you get 27. Are you with me? Do you see why I do that? I count all the possibilities. The possibilities are, in this case, those 2 positions are fixed. So this is 2 and this is 7. There are 2 times 7 possibilities of filling in this information, so it's complete. So I know the gender and I know the day. Okay, and that would be 14. And there are 14 possibilities here where I fill in the gender for the oldest child and the day when the child was born. So that's why it's 2 times 14. And why do I subtract 1? Because there is overcounting. Those 2 vectors have 1 event in common, which is girl Wednesday, and that's why I subtract 1. That's how I get 27. Now the probability that they were both girls is this: is that girl Wednesday and the other girl is born on who knows what day. Okay, girl Wednesday, girl S. How many possibilities are here? Here there are 7 possibilities, or maybe I'm witnessing the youngest child, and the second is a girl. Yes, 7 from days of the week, exactly. Okay, and what is this? This is also 7, and they have again 1 overlap. Girl Wednesday is their overlap. So we have 2 times 7 minus 1, 13, and the answer is 13 divided by 27, and that's even farther from the first question. How much mistake in which you have made? So probability, it's my lecture here, is extremely treacherous if you're not careful, if you cannot think very well. And now the conversation will get slightly more dangerous, because who knows what opinions you have or what are your interests. Okay, so you might look at this question and you say, that's not important, right? It's not a question that I value. It's not something I come across in real life. And here is what happens, guys, right? And again, I will try. Kirill, speak up, or
Yeah,
how do I?
I just want to know, what's the significance of the days of the week in determining the probability? Like, how does that apply to whether it's going to be a girl or a boy?
It applies because you have to understand what information is now possible, right? So it's more difficult, I would have to say far more to convince you of that, right? And if you are interested, again, I will talk about it in probability theory. Remember, I invited you, I tried to entice you to come to the class. 2 people came, and there I don't present probability as something interesting or not. I right away start teaching it. Okay, you will understand the subject, at least you have the same chance of understanding the beginning of it as anybody else, because it's arithmetic. It's the precision of counting. So it's very, very base, very elementary, and yet extremely treacherously difficult to understand, because you have to think very clearly. What matters in this information is you have to understand that what you are counting is, you see, what information is now included, right? So you now know that basically we have once I have this information, you should here is very roughly what's the situation here. The more information you have about a particular person, the more it will approach 1/2. You see, so all the answers I can get are going to be 1/2 or less, because you see the very some people said 50%. Now, why did you say 50%? You assume right away that you know very much about the individual. You see this girl and you kind of imagine, you don't even realize that you assume that. You imagine you took up all the information. It's the oldest child, and this other thing is, the youngest child is a girl, or it's the youngest child and the other child. You're asking what is the probability it's a girl. Okay, so each information like this updates, makes this person more personable. That's what I will say up until today. Are you with me, guys? It will make a person more personable. The more I know the person, the more it will approach 50%. And if you're interested in deeper understanding, by all means, join my probability class. It's very interesting, very challenging, and yet you can do it. And I will know you as somebody better. I have some people from my previous classes that at least decided to brave and audit it, and some people either from this or from my evening class that sat through the course. I don't know what was their impression. I just taught something very basic. The video of the first lecture is posted on my website. If you are asking for it, I will even send you a link, but you can find it very easily. Good, guys? So here is why I mentioned, when everything was happening, I was actually teaching probability at Hunter College, just the same as I do today. And here is what I will do sometimes in this course. You know, what astounds me and upsets me tremendously is that many people follow what I say blindly. You just believe me because maybe I'm a person of authority, or at least relative authority. And I will try to give you purposefully wrong information. Do you understand that? I do that. I correct myself so far because I'm still working here, but I thought about doing that. To teach this course entirely incorrectly, because people are, you know, they just don't care about it, and then they will memorize information, write something in their notebook, not think about it, and assimilate wrong facts. And by the way, guys, it happened to you many times. That's how you see. So you don't care about a certain thing, you assimilate the wrong facts, and then there might be a moment when you start caring about it. But those facts are sitting inside of your organism already, and you cannot dislodge them easily. You understand? So it builds and shapes your personality. Socrates believes that lying damages your soul. If you do not think about proofs for this course, you are damaging your soul. That's my take on it. And this is what happens to people that just follow blindly. They forgo reasoning and you know, don't argue, don't dispute, accept something or reject something. That is what will happen. It is what happens. So now the conversation, and I warn you, becomes a bit dangerous. Why are we speaking through Zoom? And I want you to tell me the true opinion that you have. Why is it that we're not sitting together in a class and you don't see my full body? And I don't hear your voices, your precious little voices. Why is that the case? I'm seriously interested in your answer. And anybody, I see one person from yesterday, Alejandro, I hope you can hear me. I very happy to see you here. From all of you guys, all of you, I'm tremendously happy to meet you, and it is tremendously upsetting that I hear so few of you, or see so few of you. Okay, so thank you, Ibad. Because of COVID-19, it would put everyone at risk if we go to campus, right? So we need to stay away from each other so that we don't spread the infection. Why don't we do that with the flu? Why, let's say, one semester, we kind of don't think about diseases at all. We're young and happy, and suddenly there is a vaccine against the flu, and that's an interesting kind of take on it. Vaccine against the flu, maybe, right? It doesn't work, by the way, all that well. But that's yes. So and most of you don't take it. So I mean, if there is a vaccine against the flu, there isn't a vaccine against COVID, but there is a vaccine against the flu. All very interesting takes. Anything else that you would like to add? So let me tell you why you're here, right? So you're asking me, and again, don't agree with me, guys, right? I can only tell you the official justification, right? There is an official justification of why we're here, and there is possibly a completely different justification, okay? Are you ready? So you are not coming, that's the take from this class. You are not in calculus because of calculus. And I will explain to you in a moment why, okay? Again, guys, right? And I want you to think very, very carefully, right? So, and if you disagree, of course, right? You have completely underlying different conditions, right? So here is why everything happened according to the official justification. Okay, and I'm not expecting you to understand it now, but we are going to go through the material that will make it understandable eventually. Okay, we are not here because of the logistic model, right? So the logistic model is describing, it was used, I can show, I linked a few videos where you can see that. It's essentially exponential growth, but exponential growth is not sustainable, so it tapers off. So logistic model is the model that was used to describe the spread of the disease. Are you with me? And we will try to, at least I'll tell you what this model predicts in a moment, right? So this is the differential equation for this model. It roughly speaks that when infection is very, very low, just at the beginning of it, it grows exponentially. And then afterwards tapers off, okay? That's, we will learn what derivatives are and what this means. So during the better part of this class, so the way to solve this differential equation, that will be the very end of the class, we will learn integration theory, okay? So this, to understand what I'm doing in here, in this calculation, look at it. I integrate it, I use partial fractions, I use logarithms, so you need to know exponential functions, logarithmic functions. You need to know, you have to solve even a simple equation like this, you need to know quite a lot of mathematical tools, okay? But upon simplifying P, I get this formula. Okay, so let me explain to you how to interpret this formula again. Right? I'm trying to kind of show you that here is the logistic equation. Here is something that officially, at least on YouTube videos that I linked, was used to explain why this quarantine measure was supposedly important. You understand me? Good. And this is what this is saying. So 1 here, guys, represents the total vulnerable. So I scale this so that the equations are simpler. 1 here is the vulnerable population, the biggest possible population that can be infected. You understand? So some people are, for some reason, immune. So not everybody will get sick, but 1, or even have any sort of reaction. But 1 is the entire crowd, the entire population that can be possibly infected. And so what this equation is, what is P0? P0 is the initial population. So when you start observing, P0 is the population that population 0, you understand, or patient 0. How many, that's a fraction in my formula. I can rescale it, but here it's a fraction smaller than 1. How many of those vulnerable people is infected? Okay, now look at it, right? So so again, how many things is this little problem involving? Properties of differentiation, that's the tangent line problem. Integration, that's the area, okay? Natural logarithms, and e to the x. Okay, so and this little number e that you see over here, it's such an important number. If you go through probability, you see it all over and over and over again. We will talk about it later. And this number, if you speak playfully, is responsible for you waking up on the wrong or the right side of the bed. Obviously, it is responsible for the grade that you will get in this class, and that goes without saying. If you don't know this e, you know nothing of calculus. Okay, and here is this thing, right? So we are keeping away so that we do not spread the disease, right? Some of you have said it, right? So we don't want to spread this disease. Now the question is, can you see this question, guys? What do you think this equation? And maybe I'm asking a question that you cannot right away answer. What do you think this logistic equation with which this lockdown was justified is saying about your eventual likelihood of getting sick, no matter what you do? If you quarantine or not, if you if you wear masks or not, what is this equation? This equation says about, and I'll help you, right? This is the limit, right? As time goes on, the answer is 1. Limit as t goes to infinity. We will talk about those limits again in this class. The answer is 1. What do you imagine the answer means? Can you interpret it? Remember, 1 is the maximum maximum population, that can be infected. I scaled it, so 1 represents the full vulnerable population, and anything else is a fraction of it. It's how many people can be infected. So as t goes to infinity, as time goes on, we get the answer to be 1. Okay? So if you study, guys, how many of you, perhaps tell me, how many of you are studying medicine or biology or anything related to that? I would be happy
Professor,
to
I have a question.
Go ahead, Alexa.
How would if the limit is infinity, then how is the answer 1?
No,
Wouldn't
of what? The time. This means as time goes to infinity.
Ah, okay.
And again, I am obviously not expecting any of you to understand those formulas. My only goal, guys, my main goal is to try to convince you to study those things seriously, to think about it seriously. That's
So like
pretty
apply
much
in the real world? Okay.
the real world of well, I mean, whatever you call the real world, right? I would like you to think in a broad sense of thinking. You understand? So very many people, they are asking, well, how is this used in the real world, and how is this used in the real world? They are asking very limited questions. Understand? So it's like you have to think of the building or of the city or of something very, very global. Okay. My position is this. If I may tell you ahead of time, my position is that what you try to develop is not so much understanding of a limit or what is t or what is e. You are trying to develop an ability to think, and that's a very, very difficult thing to do, right? As much as I try, I am not always sure that I'm able to do that. Understand? Very, very, very few people, and at very, very few instances of time, are able to think. Mostly they just react. That's my take of it, right? But going back to this question, guys, can you interpret it, right? And again, you can look at links, right? And this is the way the lockdown was justified based on this logistics formula. I included those links below. You will see it in YouTube. So what does it say about the chance of eventually getting sick, no matter what measures you take?
That there's a likelihood?
Well, obviously there is a likelihood, but what does it say? The fact that I get 1, which means what? Any idea? That everyone, thank you so very much, that everyone, let's say in the absence of something that will disrupt this model, that everyone will get sick eventually. Do you understand? So this is saying this, and that's one of the reasons I actually present this argument. So no matter what you do, no matter if you stay away or not, if you hide or not, you will catch it, right? You will catch this illness if you are part of this vulnerable population, right? So in a poetic way, that's kind of there is a poem in Russian, a very beautiful poem, right, about it. It's called a festivity during the plague, right? And they are partying during the bubonic plague, drinking and perhaps breathing in the noxious poison out of the breath of a beautiful dame, of a beautiful girl. So that means that everybody will eventually get sick. And heuristically, I can tell you, right? So I know a few people, right? One friend of mine, her mother is vulnerable, or so she thinks, to this disease, and she has actually 3 dogs. They were all hiding inside of this house, not coming out for 3 months. 3 months not seeing daylight at all. And based at least on the test, I mean, she kind of got sick, and maybe she lost the taste and whatnot. So she did get sick. She was hiding, but she gets sick. You understand? So if everyone who is destined to get COVID will eventually get it, why is there a lockdown? Again, guys, right? You can say many things. I'll mention below regarding this model, what I think of it. But if this model is true, right? That's the model that they use to justify the lockdown. If everybody gets who is destined to get it will get it, so why are we hiding?
To give them enough time to make a vaccine?
No, that's a good idea, but to decrease the rate. right? Vaccines, and that's of course something I cannot judge, but vaccines, guys, take many years to make, right? So they say 1 year at the very least, but really far longer usually, right? It usually takes 5 to 7 years to make a vaccine and test it. I will speak about vaccines below, in fact, okay? You see, guys, I want to show you something today that's regarding, so to slow down the spread, okay? That was the hashtag flatten the curve, right? And how many of you, before I move on, how many of you believe in science? Right, I believe in science. I want you to write with your blood, I believe in science, if you believe in it. Write in the commentary. So that I will remember you. Okay. Write it. Good. Okay, thank you so much. Now you cannot imagine what it does to me. It creates an apoplectic shock. I get so irritated when I hear that, right? I think, my God, what are you? Are you religious? And you can be religious, of course, but you understand that's an oxymoron to believe in science. It's an oxymoron to believe in science. You don't believe, you doubt, you think, right? That's very, 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 very bad statement, which I hope you will unlearn. Those that believe in science don't understand it, okay? That's why everything is called theory. That's why everything is called, you know, what you do is you justify it, right? So even something like flat earthers, some people say, oh, flat earthers, right? You can say it's a very strange type of idea, but unless you can explain why the earth is round, you are a believer of sorts. You understand? Maybe you can say, well, here are my commonsensical ways of thinking about it. But again, remember it. What is the difference between knowledge and belief? Knowledge is just some argument. You understand? You build an argument, an explanation. You present a body of evidence. You argue a case. If you do anything else, if you say I believe in science, that means what? That means that you worship something, but without understanding it. And that's very important. Okay, so this is, so when I drive around, I see, of course, something like this. Outside with no mask, forget about it, right? And, all right. And such messages, you know, that's a propaganda message. That's not an explanation. This is an attempt at an explanation, yes? So this is your flatten the curve, right? So why we try to keep away? That's what they say. We try to keep away because if you have this sharp curve, you see the areas under those curves is the same. Area represents 1. The area under this curve is 1. The area under this curve is 1. That means that the total vulnerable population will get sick. But if they get sick all at once, that's the idea, hospitals will be overwhelmed. The medical system will be crushed, and the critically ill people will not receive treatment or adequate treatment in time, and more people will die. Whereas this means I am trying to make the vulnerable population get sick slower, and then I'm able to then treat each of them. Right? It's like if you have 1 million guests coming at once, you cannot greet all of them. But if you have 1 guest at a time, you can deal with them. And at the start of the crisis, what was the argument for the overwhelming of the hospital? Well, so one thing is that they say the virus the virus rate of infection is alarmingly higher than that of the influenza. That's what they said initially when information came about. They also said that COVID is 5 to 10 times more lethal to the host. More lethal to the host. Yes? With me, guys? I'm not done surprising you, or perhaps at least, you know, I showed you something in probability. We will continue talking about probability. I want you to get something. And then, of course, that the huge influx of critically ill patients will overwhelm the healthcare system. That was what they said. Okay, so one thing to mention about the logistic model, right? When I realized they used the logistic model, I thought, my God, I imagined my calculus students. They usually take Calc 1 and not Calc 2 and not Calc 3. So they think in one dimension, you understand? So they consider optimization problems in one dimension with only one parameter. Besides the logistic model, it's a very primitive model. It's it makes me wonder if people that produce it, why are they not predicting hurricanes, you know, a year in advance? So again, to emphasize the points that were made with the hashtag flatten the curve, and some explanations are included, some videos about are included. So you believe me that at least verbally that was the justification, so to speak, intellectual justification, mathematical justification for what's happening here. So everyone within the target population will become infected. In other words, the total number of people that will get sick will be the same no matter what. And again, guys, it's not that that's what I believe or not believe. It is what the logistic model is telling you, if the logistic model is to be interpreted as the correct model for this pandemic. Do you understand? Preventative measures, like perhaps masks, social distancing, etc., might reduce the rate of infection, and therefore the total number of people that get sick is slowed down. So it's just at every given moment of time, there are fewer sick people, and then hospitals might manage to deal with them. Right, and immediately, even when they were talking about, they thought, my God, right? So optimization in Calc 1, those people need some Calc 3 lessons. I hope you will continue to Calc 3. Okay. Now, I should say, and so I should say a few things about the possibility of vaccine. Okay, that's beyond my ability to judge. I cannot tell you anything about that possibility because, well, I'm not a doctor and I have not dealt with viruses. But over the summer, I have translated a few videos, some in Hebrew, some are from German. And so you should know the following, right? So there are some prominent virologists, among which of them is Professor Dr. Sucharit Bhakti. Okay, if you have the patience, watch this video in full. So this is the latest video that came out. Here it is. Okay, he presents a very short summary of immune response to different diseases. Are you with me, guys? Yes, yes. I'm hoping you're interested, or at least that if you're studying medicine or if you're considering what's happening, that you're interested in what I will present still. Okay, so Professor Dr. Sucharit Bhakti speaks very frankly. His opinion is that the idea of trying to create a vaccine for this particular illness, with the way they understand vaccines today, it's as intelligent as trying to push an elephant through the needle's eye. Understand? He thinks it utterly ridiculous, stupid. And he actually developed some important understanding of the immune system, you know, during his research time. So this is the video I translated. It's in German. And here you can, in the second video, that's the latest that came out just a few days ago, that was his presentation in front of the medical community for, you know, in Hungary, I believe, right? So this is this video. It will start getting you first. He gives an introduction because what he says is not entirely popular. Somewhere in the middle of this video, you will start seeing his point of view. And Stanford professor Ioannidis, you can see a link below, has a similar, although not as sharply expressed opinion. So there are a few very important people that speak against it, but it's not commonly heard. So let us return to probability, to questions that say, well, about what you understand about, say, so you claim this disease is very infectious. How do you know that? How do you know that, right? That this disease is much more dangerous than the flu. How do you know that? That's the question that we will consider mathematically, okay? So first question, guys, and here we're back at probability. Suppose that a test comes positive, that you tested positive for COVID. How certain do you think you should be that, how worried should you be? Maybe worried is the wrong word, maybe you don't worry, you're young, right? But how certain should you be that you have the virus? To make this question precise, suppose the test that you use is 99% accurate. And what does it mean? It means that, you know, tests are only detecting what you have. Are you with me, guys? I see a few of you moving your eyes left and right. Are you with me? Do you hear me? Cool. Are you still interested? I hope you are, right? Are you so good? And if for some reason something is strange to you, by all means, you mentioned that you don't have to worry about it, right? So tests are only detecting what you have. You understand? So either it's basically a test. If I test you, I am trying to figure out what you know. And I can always be mistaken, you understand? I can always say, I can conclude that you cheated on the exam where I'm wrong, right? Every test is fallible. So this test is 99% accurate. In other words, if you have the illness, 99% of the people that have the illness, the test will detect that you have it. And if you don't have the illness, the test will incorrectly conclude that you have the illness 1% of the time. You understand? My question is, based on this information, you test positive. How likely is that you have the illness? Simple question, right? Assuming those are the numbers. Okay, and don't be scared, guys. Tell me what you think. You know, 99%, Dragon says 99 out of 100. Okay, cool, 99%. Cool. Everybody concedes that it's 99%? What's the other 5? You mean 99.5 or 99%? Would anybody, by any chance, guys, of the people that I haven't heard that are muted, tell me something, smile to me, or frown at me? Well, the idea is regardless if you are symptomatic or not, Alexa, wonderful question. No matter what, we are making it simpler, right? We're saying, let's say this test, we somehow know this test always, so 99% of the time, if the virus is in your body, it will detect it, no matter, even one virus, I mean, let's say, right? It's much more complicated, really. But suppose that in your body, you have this virus. If that is the case, the test will detect it 99% of the time. And in your body, if you have no virus, no COVID virus, only 1% likely that the test will give you incorrect information. Will say that you are sick, yet you are not. I mean, sick, I mean just have the virus, okay? Medical students you are, right, guys, right? Or who knows what others. This is something I think should be interesting to you. If you're psychology students, it should be interesting to you also. So a bunch of 99s. Anybody wants to add to it? Guys, it's morning. I haven't slept myself. I don't know how you wake up. I don't sleep at night. I mostly speak to Germans at night. That's what I do. You see? I got insane, you understand? I mean, some person recommended 100 years of loneliness. So? And again, guys, I do hope that if it's interesting to you, that it's in German, you bear through it, and roughly in the middle of the video, he starts talking, giving the punchline. So Zakia Khan says 50%. And you, Alejandro, what do you say? All right, are you ready for the answer? So this was a tricky question. The answer is this test is completely meaningless unless you have some very specific information, right? Based on the information I gave you, this is completely meaningless. Let me explain why. I have to have some awareness of the prevalence of the disease within the population, right? So P is the likelihood that I randomly pick a person, and the person that I picked has the illness. And I have to, what's the likelihood without any test, you understand? So for instance, imagine that you're living in a population where for some reason you know 100% that P is equal to 0. Then no matter what the test is saying, the answer is wrong. You understand? If the test is saying it's positive, the test is wrong because you have a more concrete knowledge that this P is equal to 0. So you understand? So this test looks like you think, well, what wonderful. So much information is here, but the true answer is it's absolutely impossible to tell. And we will talk about it in probability. If you are curious, I will explain. If P is 0, that's not, right? What you must do is this. This P in the general population is generally not known. I mean, how can you take this huge population and know exactly how many people are sick in it, right? So the statistical method to decide what this P is, it's called beta distributions, okay? So what you have to do is you have to select a random sample of people, big enough random sample of people, and very, very carefully investigate them, okay? You don't need to select, you don't need to go and test every single person. Oh my God, let's start testing. No, you have to select a random large sample of people from population, and that will generate the following. Let me see if I can show you to you, right? Here, guys, this is the beta distribution. Can you see it? So let me show you. You see, look at the math. Look at the math of the beta distribution. To answer this question, look at the math that is required. Here you can see the beta distribution change. You see, you have integration, which is what we learned at the end of this class. We have all sorts of very, very interesting, cool tools, which if you are a little bit interested, I can try to explain to you, right? Of course, it would be an extra effort if you decide to join this class or attend some of the lectures, but I teach probability. I also post those videos. If you're interested, you can learn it very fast. You can learn it now. And if you do, I can definitely write a very good recommendation letter because you actually do something above and beyond. You actually truly try to understand something rather than just pass some very, very silly class. No matter how hard this class is, it's going to be a very silly class, because we are only at the very beginning, okay? You understand what I'm saying, guys? And here is, have you ever heard of this expression? A philosopher is a blind man in a dark room without windows, searching for a black cat that is not there. I actually use this expression very often when I introduce complex analysis, but it is also, by the way, true here in statistics. And here it's a bit more commonsensical. If you search for something that's not there, you will always find it. I'm not saying, by the way, that the virus is not there, but I'm saying the following. If you search, if the virus were not there and you were to search for this virus with this test, you will find it. Do you follow? Because all tests are fallible, right? What you can generate is noise. And now, next question, and answer again with your full intuition or knowledge or anything you like. So is COVID much more dangerous, more infectious, than influenza? Why isn't there a lockdown every year? That's the question, right? Because influenza, you know, hospitals get, some of them up to capacity. They are close to crashing when you have the flu season. I've seen a few of those hospitals. My grandfather used to be a biomedical engineer when he was alive, head of the biomedical engineering department at Elmhurst Hospital, the epicenter of COVID in New York. And of course, my brother also used to volunteer in that place, in the biomedical engineering department. And I have been there fewer times, but I have seen, you know, that it was always very close to crushing. So anything that you would like to say regarding this, guys, before I move on? Guys, you're black boxes here. Maybe unpredictable does not mean severe, right? Many things are unpredictable. Unpredictable perhaps means scary. Not that, I mean, as far as I know, not that much data, but all of them are, again, see guys, my question is regarding basically decision making, right? So how do you know something is more infectious or not? Maybe at the very beginning you have no idea, and as time progresses you perhaps learn something. So again, guys, I will, here are the videos that you might find interesting, right? Those are the so initial forecasts for sure predicted exponential growth. Understand? So very rapid exponential growth. They predicted something in the order of 1 million casualties, perhaps, right? Some of the more severe predictions predicted about 1 million casualties. So those are videos about exponential growth. The first video, it's called "It's Okay to Be Smart." This guy, you know, presents arguments that definitely appear very strong, right? He explains how exponential growth takes place. And the same guy has some videos about the wearing of masks, right? Why wearing masks is something that everybody should follow. Okay? And I am very curious to know what you would say about those two videos, especially. And Fatima, you say you think that the rate is equal. That's interesting. Okay, but right now, without data, there is obviously nothing we can right away say, and I haven't really mentioned the data. I just want to see well, how you react to the information presented, because you see, as I mentioned, probability theory is very treacherous, and presentation of data can be entirely correct, except with the omission of one very important segment. The interpretation of it is not. You understand? That's what I will try to show you. I'm trying to teach you to not react. You see, people react. They always, what I see, and that disturbs me tremendously, they react. They go, or right? And not this, not think. So here is some fable about exponential growth, right? So the prediction is exponential growth, and we will learn about that a little bit. So there are many fables describing exponential growth, and one of them was about some greedy king that reluctantly agreed to pay a wise man for his service. And he asked the wise man, "What exactly do you want me to give you as a reward?" And the wise man said, "I'm a modest man. Take a microscopic grain of gold and place it on the square of the chessboard. Take 2 grains and place them on the next square, and then take 4 grains on the 3rd square and 8 grains on the 4th square, and so on." You understand? So each time you double. For each square you double. So you have 1 plus 2 plus 4 plus 8 plus 16, all the way, there are 64 squares, so all the way to 2 to the power of 64. Are you with me, guys? And then what you get is 2 to the power of 65 minus 1 grains of gold, which is, if you calculate, it's this huge number. And how much is, so the grains, I mean, maybe smaller than the grain of sand, you understand? And the amount of material that will be, the amount of gold this person have asked is perfectly fine, perfectly enough to create a full-size replica of planet Earth made of gold. You understand? So he has asked for more gold that I bet you can ever extract. So exponential growth is very scary, you understand? So if models predict the infection is spreading exponentially, first it's very small, but very, very soon, or maybe not so soon, it suddenly becomes huge. Exponential growth, we are going to learn about it. is very rapid. And what is exponential growth, guys? Before I talk, does anybody know what exponential growth is? Because some people think large growth is exponential. That's not, large is very qualitative assessment. What's large? Anybody knows what exponential growth is? What does it mean?
The
Guys,
rate of growth?
Well, rate of growth is one rate of growth. Guys, am I that unlikable that you don't speak to me? You decided to ban speech.
It's like growth that becomes more rapid in proportion based on like size increase.
It's based on size. That's actually not poorly spoken. Okay, I'm not sure who said it, but thank you. So let me, based on the population, right? So let me present to you what's exponential growth. Just again, introduction. So 2 to the x. Right, 2 to the x is exponential growth of factor 2. So basically, it's a growth. So where x is either time or maybe something, right? So so it's 2 to that power of time, for example, right? So that's exponential growth. It's in general when a is bigger than 1, it's something of the form a to the x. Okay. So in this case, you see the exponential growth. It's 2 squared, 2 cubed, 2 to the 64th, right? Are you with me? Now here is, guys, and that's I simplified the numbers, but I watched Israeli news. I see what happens regarding the situation in Israel, for example, and what happens regarding it in Germany. So they're actually going to have supposedly a massive protest in Berlin, in Germany, on the 29th of August. But here is how information was presented regarding the situation in Israel regarding COVID, and I simplify the numbers. Okay, I want to see what you will tell me. Right, so they present an alarming 7-day break, and on the first day they say we have 2 new patients. On the next day 4, on the next day 8, 16, 32, 64, 128. And my question is, guys, so confirmed individuals, basically people that tested positive, and assume that if they tested positive, let's say they do indeed have the virus. Is this truly exhibiting exponential growth? You understand what I'm asking?
Yeah, it is.
And I mean, and don't be scared.
It's not?
No, guys, I'm not saying it is or it's not. It might be a more complicated question. Maybe the answer is not is or is not, right? I'm trying to explain to you how data is presented. And the only thing I can validate or not validate is whether or not data is presented correctly. And not always, you understand? I can be fooled, just like you can be fooled. But I try not to, okay? Doubling is exponential growth. If it's doubling, it's 2 to the x. It's one type. There is a 3 to the x, 4 to the x, any number a. Say I'm checking if you're already exponential experts, right? Whether you would be, you look at this information and somebody smart is asking you, well, now you see it's exponential growth. Do you agree that we need the lockdown because the disease is clearly progressing exponentially? Do you agree that we need to close schools? We need to close businesses? We need to close restaurants, we need to keep distances, we need to put a mask on our face, and so on and so forth, right? That's for the first question is, obviously, is it exponential growth based on this information? That's indeed this. Look, I put one. It's what's happening in Israel, and I translated one newsreel that I found interesting regarding Professor Lass. You can watch this here. There are plenty of things that you can watch in case you are interested in what I'm saying. So, is this exponential growth? No, I mean, what do you mean? 2 means 2 people tested, 4 people tested, 8 people, 16, 32, 64, 128. So Kirill, you are saying no. Why are you saying it's not exponential growth? Obviously, just a few numbers. Maybe later on it will be different, right? But based on this pattern, which is simplified, it's not the way the numbers obviously came, but I just wanted to make it kind of very, simple to show you.
Actually, can I change my answer to yes?
Yes, of course, guys. One thing I want you to do, you see, I think a lot of you're trying to do psychology, right, rather than reasoning, right? You think, look at my face. What is this weird person wants from us, right? You're trying to give me what I want from you. I'm not here to rob you. I don't have a gun. I haven't yet met you. I am asking you, what do you think based on this evidence? You don't have to be worried about being wrong or right. Don't try to figure out what I'm asking you to, what I want to do from you. Do you understand?
At first, I thought it was just a multiplier, but it can be expressed by 2 to the x. So
yes. So yes, right? So this looks like it's 2 to the x, right? So you are saying the spread is, we are exhibiting exponential spread. Yes? How many of you say yes, guys? You understand? The news, yes, and it's write yes or speak, because I don't hear you guys. Or yes, thank you. Thank you. Right? Say more yes, guys. Or maybe you fell asleep. It's early in the morning. My God, I convinced you. Good, right? So you started trusting me. Exponential growth. Ooh. What about others, guys? I see only a few people. There are 39 individuals that are here. Are you sleeping? My God, we are reaching a jury consensus, huh? Isn't it wonderful? We are seeing exponential growth, huh? I'm so proud of you. Let me now, are you ready? Well, the answer is, again, guys, you see, the answer is not always yes or no, right? And let's say, I see that those numbers might be true in Israel, right? Might have been true. I mean, there were different numbers, obviously not so clear pattern, right? But the question is, that's what I'm trying to understand. Probability or statistic, or it's not what you imagine it is at all, right? It is very, very mischievous. It is very treacherous. No, that's not that they're. This means each infected person infects 2, so it's 2, right? The double. But maybe let's say he got healed, and now there are 2 more. You understand? Each person infects 2. Those numbers reflect. You understand? Reflect doubling. Okay. Don't, guys. You see, you agree or don't agree not because what I want. Okay. Agree or disagree based on your reasoning. If you see exponential growth, do you see that? You agree with me, right? It's exponential growth. Let's say what they present on the Israeli news is correct. In other words, those are true numbers. Today they found 2 people. Tomorrow they find 4, and then 8, and then 16. So they will, let's say they will find that, right? Is this necessarily exponential growth? It could be not, right? So the answer is false. Now let me explain to you why what's so false. In other words, it does not necessarily mean that. You know what I'm saying? It could mean exponential growth. It could not mean. There is an important information that was omitted. And what is this information? Imagine that here is what you can do. And that's, again, something has to do with slope. So on day 1, you test to 10 people. Here. On day 1, you test 10 people, and 2 of them are positive. Okay, you don't test the entire population, obviously, right? 2 out of 10 are positive, and we get worried. My God, right? So we test 20 people on the second day, and 4 of those people are positive. My God. So on the third day we test 40 people. 8 of them are positive. Keeping this up, on day 7 we test 640 people, and 128 out of them are positive. However, look at this. Take the fraction, and the fraction is the same. That's a scenario where, I'm not saying that's obviously the scenario, I don't know. I'm just saying that they present it on the media. And if you don't know mathematics, you're right away, oh, exponential growth. But they omit something very important, by which the information is meaningless. Unless I know this, what they said to me is not important at all. I don't know what they did, right? What happens here is, instead of exponentiating instead of observing exponential growth of disease, I exponentiate the number of tests, and that's just a scenario. You understand? That doesn't mean that that's what happened, but that's I'm just talking about how the information was presented. It was presented by only giving partial information, true information, but this partially true information is meaningless. Do you understand? What you have to do, guys, and that's called normalization, you have to describe how many positive tests you have per, let's say, 10,000 people, or depending, you just select a population. You want to keep a constant test population, how many people were tested, and based on that, I need to know based on that, I can judge if there is exponential growth. You understand? If the same number of people was tested all the time, and I see an increase in infection, I can perhaps predict exponential growth, right? But this might be exponential growth, or it might be exponentiation in number of tests, okay? And you think, what do you think? Do you think this is meaningless? Let me explain to you what happens in Germany, right? Because again, in some sense, my mind over those 3 months was in Germany, and I was speaking to my friends from there regularly, and I was watching their news and all sorts of information about it, right? So here is what happened in Israel, and here is what happened in Germany. In Israel and in Germany, especially in Bavaria, there was a very severe lockdown, much more severe than here. You were not, at its height, allowed to leave your house without a particular purpose, without going to the grocery store. You could not walk on the street without wearing a mask. I actually have seen it. My friend from Israel, right now he goes to a bar and they still enforce this law, right? And the bar has to be called something else, and I see what they do. So when they're in the bar, it's crowded, the mask is off, they drink, then suddenly police comes for inspection, they get the order, put the masks on, they put the mask on, and they pretend that they carry out the guidelines. You know, it's called pretending that you're a fish. There's a book like this, right? Pretending that you develop gills. And here is, there is going to be, I'm not sure how big, it's so disputable, but the enemies of the lockdown are going to have a massive demonstration in Berlin on August 29th. And one reason for this, here is the German graphs. Let me try to explain to you what this graph means. Are you with me? So this is the distribution of COVID in Germany, right? So this is the height of the cases. This is the height of the cases, and the green line indicates the number of tests. So they were able to take the information from the Robert Koch Institute, and they were plotting the number of tests. So in Germany, there are some elements, especially from the government, that are saying the second wave is coming. So they are predicting that there will be a second wave in Germany, right? So you can see here was supposedly the first wave, and here the number of confirmed positives is going up. But look at this, the number of tests is also ramping up. This is just absolute number of tests. So they're saying, oh, we have increased in sick individuals, we need a lockdown. You with me? And that's and they present it to the public, and the public buys it up, right? As soon as they start presenting the information, it outraged me, because I think, my God, they are presenting information, and it's to anybody who learned a little bit of mathematics, that seems very manipulative, because regardless of what's the situation, you need to normalize it. Here, I'll show you what the graph looks when it's normalized. Do you see this? This is per 1,000 tests in Germany. That means new cases per 1,000 tests in Germany. This is that same peak, and look what we have over here. There is no, based on this, for 1,000 cases, it's stable, which, by the way, because tests are fallible, it looks like noise. You understand? So most likely that there is very little to no COVID in Germany, yet they continue with many of their measures, and they are possibly preparing to have another lockdown. You understand? So this is not per day. This is so that was per day. But this is all per day as well. What you need is, this is normalized. This is per what they put it not a comma but a point. If you have 1,000 tests, you will find this level of confirmed cases. You understand? So here you used to find more of them. That indicates, of course, that some people possibly were indeed sick with the disease. But here you started seeing just noise. Understand? But they say a second wave is coming, because they omit the information about the green line, and they show you the blue line, and it looks like it's rising. Do you understand what I'm saying? So it's all correct. This graph, let's say, it's correct. and this graph is correct, but without the information about this test, it's meaningless information, right? So the fact that this is rising, it's almost meaningless information. I need to know per 1,000 or per some number of tests. I need to normalize it. It's like a slope, right? How many tests per them, how many infected diseases, how many infections. And this looks like a noise because you see it's jumping the same way, and each test is fallible, and not just 99%. You know, most tests are apparently much worse. I cannot judge the quality of tests. I know nothing about it, but that's one thing, right? Now, next question is which is more lethal, influenza or COVID? Okay, and of course, how do you know? So COVID, you say, but because you what? You heard it on the news? So guys, and how do you know? Tell me truly.
Can you hear me?
I heard you, Drang. You said
so. Yeah, I work with kids over the summer and the winter too, right? When in the winter, when they have influenza outbreaks, we don't have to wear a mask or anything. But because of COVID, I have to wear my mask when I'm around.
But that's just you're told to put something in your set because I tell you because of Santa Claus. That's not an explanation. All right, you have to wear mask because of Santa Claus or because of what? How do you know? And again, I mean, you might be really. I'll tell you afterwards what about it, right? Which is more lethal? You can't say it without data, right? Exactly, right? So we'll present data now, okay? Again, guys, I hope I'm driving a very interesting point to you, right? Whatever you believe, I'm not gonna try to change it, right? My goal is to teach you mathematics and hopefully to teach you to think. I'm not sure I can think truly. Again, you understand? I make mistakes. I can be misled. Everybody can, right? But I'm trying to show you that it's very easy to mislead you, right? By not lying. You don't need to lie. You just present information in a way that somebody will react to it, because well, people are not very trained. They haven't thought about many things. Okay, so let's try to consider which is more lethal. According to the CDC, and that was one German, actually, one of the proponents of the lockdowns, a smart person actually, he basically tried to explain to me. He explained to me what is his opinion and how he justifies that the lockdown, or basically that there was indeed a very, very serious situation. Okay, and this is one of the graphs that you can find on CDC. This is US mortality. Okay, look at this graph very carefully, guys. So what it says, it's in percentages. You understand? Very important. It's percentages. And what you see is that, well, here is some peak. That's the influenza, possibly, right? And then you see it's roughly exhibiting some sinusoidal wave, this pattern. And then suddenly there is a spike. What is this spike? This is percentage, 27.5% of mortality of death certificates listed problems with the lungs. You understand? Some sort of lung infection. Do you understand? Look at it. Look how big, right? You have this green. You know, it's kind of big here, but it's 10%. I guess there was 2018 was maybe a particularly bad flu season, right? And then as you go on, oh my God, right? 27.5% of mortality. Notice of mortality data is listing lung inflammation. So, is this good evidence? My next question. You understand what I'm asking, guys? You look at this graph. This is what the CDC presents, right? They say 27.5 of all death certificates for this period in yellow, the height of the pandemic, listed pneumonia, influenza, and COVID. Now, this is all combined problems that have to do with, I guess, I want to say in German, I forgot how do you say it, lung infection, Lungenentzündung. How do you say that? Lung. Well, when you have a lung infection, you know what I'm talking about? That you need to take antibiotics and whatnot. I think they call it pneumonia in English. Maybe there's another word, a simpler one. Yes, but influenza was here. You understand? I mean, really, what was new today? It's COVID, right? Let's say that you see most of this orange region is probably percentage of death certificates that were listed with COVID. Understand? Because look at it. Here there are some peaks. Essentially, it's not that high, right? So this is listing all infections, including COVID. Most likely, the bulk of those orange percentages is due to COVID. Is this good information? Oh, very good. Let's see if it, and one person, Ibad, I think you nailed it, right? Percent out of how many people? So again, other causes. You see, obviously there are many other causes. So many of Alejandro, all of this. Thank you, by the way. I was hoping you're still here. So there might be other causes. Okay, and that's the very first thing I noticed last semester that infuriated me truly. Right, is that I'll explain to you below with a story why. Okay, so it's hard to say, especially for a person not in the middle of something. You know, we see only very little. We only see as much as our eyes, at the level of our eyes. So what does this look at? The information possibly is entirely correct. It tells you how many death certificates listed. Let's say all of this orange line over this overflow is death listed due to COVID. Understand? Let's say all of it due to COVID. Because again, influenza and other problems, I mean, would possibly be the same. They are the constants, possibly, right? COVID is the new thing. So a lot more death listed COVID as a primary cause of death. Okay, what's the problem with this table? Let me show you. So see, the devil is in the details, right? The graph might be very meaningful, or it might completely be not meaningful. What is the problem is, and that's very difficult to notice. You think very intuitively, well, you're completely healthy as a cucumber. You get sick suddenly, and then suddenly it's hard for you to breathe, and suddenly you need hospitalization. Yes, and your situation in the hospital is only getting worse, and suddenly you need to be attached to a ventilator. Right? And that's, you assume, oh, it's common sense. The person got this new virus, and that's the reason the person deteriorated, right? Maybe there were other things that finished him off, but the virus was the primary cause of deterioration. But the truth is a bit more complicated, right? There was a strong pressure in all the governments, in all the hospitals, and few people actually dare to speak about it, to list COVID as the cause of death, right? So how do they decide if you test positive for COVID and you're dead, your body tests positive for COVID, they put it as a primary cause of death. You understand? Or very often they have put it as a primary cause of death. So there were cases, apparently some doctors in Israel said that had some person crashed and died because of a motorcycle accident. They found COVID in his blood, and they said, well, he died from COVID. And what else? There were also guidelines to list COVID as a probable cause of death, even if there was no test confirming that the person had COVID. So they just decided. So main thing is they said, if COVID is found in your blood, then that's the cause of death. Understand? And that seems, well, of course, COVID is a dangerous disease. What's the problem there? Let me explain to you what's the problem. If you do this without listing the population that died, I can just relabel from one cause of death to another. And here is what I can prove. I can suddenly prove that hospital deathbeds have become extremely dangerous. Are you with me, guys? They have become extremely dangerous. Here is my simple scenario. Okay, imagine there is a certain hospital, and each April there are 100 people that die of various causes in that hospital department, right? Let's say that happens all the time. So the death certificates list various causes, but suddenly there is a strict guideline. It says list hospital bed as the cause of death if the person is found lying on the bed or near it when the person is dead. You understand what I'm saying? So you know what would happen, right? So what would happen if I do that? What would be the yellow spike? I can make it 100%, you understand? Because people in the hospital that die, they all lie on a bed. Why don't I put this as a cause? So to combat that, it's vital to list how many people are dead from all causes. You understand? So you go. One thing I look at some comments. Right? I see what people think about the situation, and there are some people that say I think COVID is as bad as the influenza and not worse. It's as deadly as the influenza and not worse. Prove me wrong. What do you hear in response? In response, you see they say from influenza yearly, according to CDC or some other places, about between 30 to 60,000 people die from influenza yearly, right? 60 being some sort of an upper bound, right? And according to the data now, over 170, maybe 180 people died of COVID. That's what they say, right? They died of COVID. But the problem is, which I right away noticed and bothered me very, very strongly, they list the number of deaths from COVID so easily, but they don't list how many people died from all causes next to it, not just for this year, but for the years before. I need to see data for many, many years. What's the average of dead people during previous years? How much it fluctuates? I need to have statistics. See, it's not always the same number. It jumps up and down. How much is it fluctuating? How much is the death overflow? How many how many people died extra? That's important, you understand? So, because otherwise you can be guilty of relabeling. The extra deaths or mortality overflow is very important. Do you understand what I'm saying? But check on Wikipedia or check anywhere, you right away find how many people died from COVID and go try to find how many people died elsewhere. And they have these graphs that list percentages. I want not percentages, but full numbers. Now, here is some more information, right? So some British guy suggested that I actually can find death rate information in Britain. In Britain, they keep better records. So I looked at, and actually I cannot see for farther than that, but I saw the total number of dead people in Britain since 2009, and including this year up to April or May, I forget, right? And this is the graph that that this guy suggested that came on British channel. So you see, this dotted line shows average over 5 years of how many people died in Britain. This black curve shows extra death. Understand? This black graph, sorry, shows the death for this year. Look at it. So January, it's kind of slightly below the average. Then by March, for the same time, it starts getting over the average. And here it climbs. Look how much, right? In April, it climbed twice. In April, twice as many people died. I actually than the average, right? The average in some area where this graph was generated was, well, let's say 12 or 13,000, and 25,000 died in April. Does this now show that this is much more dangerous? The British guy said, for example, he had a very sinister theory. He said that British people will not believe that there is a dangerous disease out there, and they will not abide by lockdown rules unless they see many people die. So he thinks, he is a supporter of lockdown. He says that, well, they waited for the population perhaps to start dying, so then people start getting scared, and then they abide by the lockdown, and the death rate goes down. That's his take on it. He's, again, not stupid at all. He knows statistics, you can tell, based on what he said, what he speaks, right? So what do you think? Does this graph show that COVID is that deadly disease? I can tell you what I did. I also found the numbers, right? And I found that in April, about 5 standard deviations away from the norm, from the average, was the death rate based on the sample I was able to obtain, which means it's an outlier. The number of deaths in Britain based on the data I was obtained, was an outlier, which is highly unlikely if situation was just as it is always. Does this show that the disease is highly dangerous? Guys, I haven't cooked your brains just yet, right? You're still with me, and I'm hoping that you find it very interesting, because it is going to affect your life one way or another, what you decide.
Well, I have a question. Is this just deaths from all causes?
From all causes, which is what I was
in 2020.
In 2020. So look at it. You see this dotted line is the average over, I think, 5 years. I found average. It's actually slightly less, 4 years. 2015,
okay.
2019. This dotted line is the average, right? And the black line is the particular death rate for. You see, really, it's not a continuous curve. It's at 31 January. This is how many people died. At 28th, this is how many people died. 27, this is how many. You see, it's roughly going with intervals of 1 month. And this is how many died in April, roughly here. You see. So
of COVID, or did just
of
a
all
lot of
causes,
people just happen to die during
all causes.
Okay.
So which is what I mentioned. You understand why I needed all causes? Because this graph, I see too many. So I see this. So many people, when they say, oh, obviously COVID is more deadly than the influenza, and how do they justify? They say that from COVID, 180,000 people died in the United States, and from influenza, it's never in the past, who knows how long, has never reached more than 60,000. You understand? So so this disease is then accordingly much more dangerous. But they never mentioned that the problem is relabeling. Unless I know the total number of, it's very difficult to determine why a person is dead. There are comorbid causes, right? So that a person might be dead from many causes, or you might relabel something. Understand? So I can generate without mentioning numbers. I can just relabel. Understand? If every year 100 people die, this is percent. Look at it, it's percent. You understand? If each year exactly 100 people die of a disease, I can decide 1 year to attribute the death to a different cause. That will cause a spike. You understand? So I made it silly. I made it silly to make it a bed mattress. You understand? So every person that dies in the hospital dies on a bed mattress. You might imagine, right? So then you might say, if a person dies on the bed mattress, list it as a primary cause of death. So suddenly you would see bed mattress becoming lethal, being 100% of death rate. You understand? Yeah, but the total number of people that died is the same. So that's just a problem of relabeling. They just stop dying from heart attack or from cancer or from other causes. You understand? Which means it's false. It's an incorrect information. This graph by itself means nothing at all. They need to put not percentages but numbers. Percentage is very tricky. So the information could be absolutely correct, but in percentages it's meaningless information, because I need to know absolute number of dead people. And this, by the way, regardless of what you think about the disease, this is not. This is objective. You understand what I'm saying is objective. You are presenting evidence. I'm saying the evidence presented is incorrectly presented. That's what I can judge, which infuriated me tremendously. Right? I see on Wikipedia the number of dead from COVID. How is it that they are so easily able to tell me who died from COVID and not tell me what's the average of people dead from other diseases? From everything combined, not just this year, but another year, and just do a statistical analysis to show me an outlier. And one British person actually suggested that I can find this information on the British statistic. I forgot what it's called, Royal Statistics something, right? So this is some of the things that I found, and I found the actual data. Do you understand? This is absolute death, and this dotted line is average death. So if there were in Britain about twice as many dead people in April than is usual. And it's significant. It's 5 standard deviations away, so that's an outlier. Usually the range of death, it's no more than maybe 1,000 people, plus minus. You understand? 1 standard deviation, it's fluctuating roughly plus minus 1,000. So does this show you that it's indeed a deadly epidemic? So Alexa says yes. Anybody else? So Dragon, yes. And the other guys, are you fried or are you still with me? I want to know your reaction, guys. Right? Is it very compelling evidence now that we have a very dangerous? Well, dangerous is a loaded word, but I mean is a a disease that warrants lockdowns? So many people say yes. Well, you see, what bothers me is why is there such a big discrepancy between Germany and Israel? And you might say, well, they follow guidelines. Israelis don't follow guidelines. I've seen, you can watch in the videos that I mentioned, and I know that pretty well. Germans, it's a little harder to answer that, but let me tell you what. What can be said about this situation? So I found out that here is another difference, right? So the difference in countries is that in some countries you get treated very, very much, and in other countries you don't get treated as much. So in the United States, people like to get pills. You know, if you go to a doctor and the doctor doesn't prescribe antibiotics to you, my God, you get upset at the doctor. Okay. In other places, it's different. So let me tell you what you might be interested in. Dr. John Ioannidis of Stanford University, he did a statistical analysis of COVID, right? And based on it, is a very, very, is a medical statistician in Stanford University, and he's cautious in what he says, but he says that COVID is no more deadly than the flu. You can watch it. It's a bit technical, and you might not enjoy his style. He's a bit technical, but if you watch it, it's 1 hour and something. If you watch it, you would see his findings. You can find the articles again, right? So the death rate, unlike what was initially estimated, of COVID is about, for a person that gets infected, about 0.2 to 0.3%, which is commensurable with the flu. It is not more deadly. What possibly what I still think that more people died in New York, and I was wondering why. I found out that many people that died, they were dying in a hospital, right? And this is again, now it's a speculative thing. It's in a hospital where my grandfather worked, and I can tell you what I personally think, right? And that is by no means to be taken as any expert opinion. That's based on this nurse. There is a nurse that reported she was working in the ward at Elmhurst, and she reported that basically, according to her, people that did not need it, it was basically like a last resort. They were connected to a ventilator. Being connected to a ventilator leads to an infection, leads to death. So in some sense, the overflow of death is panic and over-medication. And regarding the lockdown, the hospitals were epicenters of the spread. So what you should have been doing, perhaps, is keeping away from a hospital unless you absolutely need it, rather than the other measures that were taken. In other words, in my opinion, everything that was done was entirely incorrect, false, and in some cases, because as this is being realized, the evidence of that is being cleaned up, because people that caused it, others will blame, possibly unjustly. In my opinion, let's say politicians that declare those measures, they declare it because people are afraid, people wanted it, but the people always blame a politician or somebody else that did it. And so I believe that that they are trying to hide the fact that what is being done is an entirely false approach. By the way, regarding, as I mentioned, right? So yes, in some sense, the measures remind me of my mom. I imagine I go, wearing a mask, but I imagine I will tell my mom, "Mom, I'm going for a duel to the death. Where is my pistol?" And she would say, "It's cold outside, wear a sweater." You understand? So yes, this is the nurse. If you want to see it, it's a heuristic account what she saw in person. You can believe it or not, that's up to you. This is statistical account by a prominent doctor, right? And the German that I mentioned, Dr. Sucharit Bhakti, he speaks a very interesting thing about the vaccine. He says that for a disease like COVID, vaccines cannot be developed fast, cannot be developed safely if they are, and are absolutely useless. Vaccines of the type. And if you want to see why, you watch the full video and we can talk about it. Naturally, I don't understand much about vaccines. It says that there is a very big difference between viruses like COVID and even the flu, or viruses like COVID and and measles, or all the other viruses against which vaccines were developed. You understand? If you are interested in this account, because soon in Germany there is a massive concern about it. There might be a massive effort to vaccinate, and there were, again, I saw confirmation by Dr. John Ioannidis. He said that in mice models, when they tested vaccines against other coronaviruses, that there was a strong reaction, and the immune system attacked the body, and there was a reaction which was much worse than the disease itself. But higher or lower, that's again all sorts of complicated questions. If you're interested, watch all those videos I presented, and if you're interested, we can talk about them. Right? If not, next class, it's mathematics. I'm hoping, guys, that I was able to show you something interesting, something that will hopefully make you want to study mathematics, or perhaps join my probability class and listen to those lectures as well. Because you see, how you learn the subject affects your ability, or speaks of your ability to be a thinker. Do you have any questions for me? You see, another interesting thing I imagine is that, did you understand what I had to say? Well, perhaps you have, perhaps you haven't. And unfortunately, and that's the last thing I should say, nothing I can do will change you significantly, right? I hope maybe you will remember it, write it down, that you would try to think about this material honestly, right? So I will not teach this class, memorize a formula. I will present information, sometimes specifically in a misleading way, because I want to see if you will catch me. Most people just write down whatever somebody tells them. Well, then I suppose, and by the way, one other thing, you interact with me, otherwise I know nothing about you. Right? I don't know who you are. I have never met you in person. I don't know what sort of student you are. Goodbye. Stay if you want to for office hours. I'm stopping the recording.